Okay, let's start. So I'm very happy to see everybody at this data-driven meetup about biases. Super happy. I am data advocate or data evangelist or many other names from Toloka, and I'll be the host today. And I hope you will really enjoy it, and I will take a teeny tiny particle in this. And actually, I am super thankful for this event to happen, and it happened not only because I am such a beautiful standing here, but also because a lot of many professionals took part in it. And firstly, I want to thank very much for this venue in which this talk happened, this OLX Group venue. And for this, I will give a mic to our Sadat, to our data science manager, everything smart guy, best organizer, to give so I'm hard on compliments today, to give a couple of words about the venue, about the rules, and about everything today.
Thank you. First off, really welcome everybody. Super happy to have you and hosting you in our offices today. We have very basic house rules. Drinks in the fridge, empty bottles go in one of these trolleys that you see here. There are bathrooms on the other side of reception. There's a door that says do not enter, do not enter. There are people maybe working there or confidential information. Everything that you see. So we also have a children's party tomorrow at the office. So please be respectful for the venue. Try not to litter too much. And enjoy yourselves. There's food, there's drinks. Once again, welcome to our beautiful office and super happy to have you. Thank you very much.
Okay, now we're a little bit cursed with technical things, but no, I'm pressing everywhere, but I want to change the slide and I can't, so I will just improvise with our our greatest organizer. Thank you, Valia, dear. Okay, so not so fast. Thank you. Jesus Christ. I finally managed. So today, thank God, to our collaboration to community with AI Guild, which are community collaborated with us on the means of helping and sharing expertise in data-centric AI and in applications and engineering. Sadly, the head of Data Guild AI got COVID, especially today, so I'm very sorry. I think with these meetups, which are now offline, I'm like, God, we are finally in this era when we can have everything not online, and boom, our head gets sick, but I will try to be as good as her and at least give you some kind words about this amazing community, because these guys were organizers of one of the best actually summits that I attended. It was also here in Berlin. It will be next summer in Berlin. It's a lot of nice topics. I met here one of our speakers or even two, and I'm it's one of the best connections that I had. And these are the talks about data science in general, about ML. They're very industrial and very interesting to attend and especially to speak there. And this community, give me a second, I'm finding a position which doesn't work. Okay, and this community is not only this has an amazing summit, but also they will be presenting this summer, so you can try to apply, or at least you can try to come here and to listen to this amazing talks. It's 3 days, it's very nice. Okay, you can I will be saying the next slide. I'm very good at this. And these are the target attendees that you can see. It's pretty much technical ones, so it will be interesting for the technical crowd. But I'm always saying that learning is learning, so you can come even if you're not feeling so technical at the moment, because people here are usually try to explain and they're very good at teaching. And the next slide, please. And yeah, I mean, of course, compliments should be seen, but I am talking also from my side. It's an amazing venue for amazing people. So you also would like to join to listen about their community, which is actually was organically grew. It's organically grown. And I was amused to talk with the director, which is not presented today, because she told that the story was pretty natural. They just met together with her colleagues and they decided to help each other out with some problems in the companies arising, like technical or data labeling or some ML stuff. And then it's just naturally grew into the helping and loving community. I wish we will to the same path and you will be you will know us from the side that we're helping each other with talking with some decisions in machine learning and AI. And, okay, so before we will start, and we're very soon to it, a little bit about our community. So we like talking about data-centric AI. I am kind of evangelist around it. We don't only, not about just data-centric AI, it's what is this, why we talk about it. We're talking about, in particular, how to help with data labeling, how to help with the pipelines, introducing and fixing all the biases and drifts with data and AI, which are like the huge problem, especially considering that we have these huge models around which are kind of seem like conscious AI, but they are still with big biases. And yeah, we kind of know how to work with that and with data. So come to our community, which is in Slack, come to our talks, and most like important for me, you can also present there because we love sharing knowledge. Community is always about sharing, not about me showing off here how good we are. So we are super happy to present at the different locations, but today we unlocked a new location, and this location is Berlin, and I love it because firstly, I live in Germany, and secondly, so you know, train. And secondly, it's just very nice to have tech talks at the Berlin because the crowd here is amazing. It's super warm and super technical at the same time. And I am very happy to see anybody coming here from MeetupCon, and please join more. We won't stop here. I'm believing this one will be a huge success for us, so we will do more and more and more. So now we will finally start with the talks. We will have 2 talks about biases today to introduce you to the sphere from the 2 different positions, from the fairness in the AI, and then from kind of behavioral biases in AI, and especially in the search engines and how to fix them. And then we will, of course, you will have time to communicate, to talk, to ask questions, to just look at the beautiful office. And then we will have a panel discussions, which I just want to talk with people, like with our beautiful attendees about, human biases. We create them, we fix them, we create them again. Isn't an infinite loop which we won't solve at all, or maybe there is some hope. So it will be a very easy conversation. I really want to introduce you also an ability to start speaking in this panel at some point, and we will have just a nice talk, nothing super specific. And I really love questions. I love asking them myself. That's why I'm hosting a panel discussion, just, why? Because I can. And that's why we also want to tell you that not only me, but also in general, our company likes questions just because they bring answers and we need them. So you definitely can ask the questions here. You'll be if you're here, here offline, you'll be handed a mic because we really want people in Zoom feel equal and also hear the questions asked, or in Zoom, and the person who gets to be the most active and interesting, of course, will get some merch because who we are without embracing the questions in this world. And I'm super excited to hear from you, Raini, with your talk about the fairness in the AI, because it's a big problem. And I'm very interested that you are gonna show an overview and we'll slowly dive in this nice and complex, pretty much complex talk of biases. So please welcome Raini.
Oh, hello. I'm a bit lethal when it comes to using one of these, so if you stop hearing me or if I'm screeching, maybe just make dagger eyes at me. So I'm here today to talk about fairness in AI. And why am I using the word fairness rather than bias? My background is in statistics. We all know bias is something that is just inherent in data, and so I think it's more interesting to frame it as fairness. How do we be fair? So, next slide. I love this quote. It's going to be interesting to see how society deals with artificial intelligence, but it will definitely be cool. And there's the CEO of iRobot, they're responsible for Roomba. Why I like this is the interesting choice of conjunction, but, which sort of implies that the first half is sort of negative and the second half is positive. And I think we're already seeing that over the last few days with ChatGPT. It's super interesting, super exciting to observe, but lots of people are already spotting some potential issues with with these newer large language models. So first, an introduction to myself and some motivation as to why we should be interested in this topic. So my name's Grania McKnight. I'm from Ireland, hence the somewhat faded accent. My background originally, like I mentioned, was in mathematics and statistics. I then worked for quite some time in fintech, first in N26 here in Berlin, then some time in Adyen in Amsterdam. I worked initially on NLP topics in N26, but I also worked quite a lot in financial crime models. So I really saw a lot where ethics comes into play, because financial crime is something that touches everybody. Every time you use your card with Adyen, it's going through one of the models I built. So hopefully it's making choices ethically. And now I work at Spoke.ai, and we are a small NLP-based startup here in Berlin. We're about 1.5 years old, and we use, among other things, pre-trained large language models. So we're very motivated to stay on top of the trends in NLP fairness and general data ethics. So yeah, next slide. Sorry, next slide. Next slide, please. So what is fairness? So I think what hopefully should become clear at the end of this is that there is no one definition of fairness. It really depends what you're applying, where you're applying it. But just to give you something to start with, there's this rather long sentence. But an algorithm is said to be fair if its results and performance are independent of given variables, especially those considered sensitive or protected. So these can be gender, ethnicity, nationality, sexual orientation, disability, etc. Next slide, please. So one question. It works? Great. So before we talk about basically look at some examples of where algorithms have been unfair, maybe we can talk about how bias can be introduced. And really, when we talk about fairness, we mean the absence of harmful bias, right? And bias can be introduced in 3 main ways. These are not the only ways, of course. The first is in framing the problem. So when you are trying to build any sort of algorithm, you give it some objective, some problem to solve. And the way we communicate is through mathematics, essentially, through our programming languages. And a lot can get lost in translation. So we'll look at one particular example of where that went wrong. Another can be in data collecting and preparing. So if the data that you collect to train your model on is not representative of reality, so if it underrepresents certain groups, for example, that can lead to harmful bias, or if it reflects existing prejudices, it can reproduce those harmful biases. And related, but its own standalone, is the model you select. So as we move deeper into deep learning, problem we're faced with is really disentangling relationships between certain variables and these protected attributes. So one thing, for example, I saw a lot in financial crime was product managers would come up to me and say, can we please use postcode in our model? And I'd say, no, because postcode is correlated with a lot of protected attributes, such as ethnicity or socioeconomic status. And really what you have to do is build a model that's based on the underlying causal factors. And it's not because you live in a certain postcode that you commit crime. It can be correlated, but that's not the underlying causal factor. So,
Can I have a question?
Yeah.
So it's about the definition of fairness you have, is because it looks very much like a bias. In fairness cases, you actually can have cases where discrimination is okay. It's something that you want to have.
Yeah, so one tricky or one common place where you could see this, for example. So a lot of people talk about fairness through unawareness, which is if your algorithm doesn't contain a variable, which is a protected attribute, then you're all in the clear. So if your algorithm for financial crime doesn't include gender as a variable, all good. But there are many cases where you can imagine using gender in your algorithm is really important. So for example, for medical tests, it actually can be quite relevant what gender you are in order to produce the best accuracy.
Or access to universities for minorities, for example, where there is actually law that requires that you actually have a gender.
Yeah, I will actually see later on in this presentation, there are different fairness metrics you can use depending on what outcome you want. So the main thing is fairness, your definition of fairness should be in line with your ethics, like what you ultimately want to achieve, which kind of comes back again to this alignment problem. So this is this article, and these materials will be shared with you after, and you can follow the link and read it at your own leisure. But this is a specific example of what's called the alignment problem. So this study looked at searches of STEM job postings, and they discovered that they were shown far more often to men than to non-male searchers. And when they looked into why this was, they saw that the algorithms that were deciding which ads to deliver to the end user were optimizing for lowest cost per click-through rate. And it wasn't the case that the click-through rates were different among the males and females. It was actually that females were more expensive to advertise to. And because they were optimizing again for that low cost per click-through rate, they showed it more often to men. So the problem there is not that the algorithm was actually doing something wrong, per se. It was doing what it was told to do, but it didn't maybe match the ultimate goal of whoever is posting this job or serving the job postings. And that's one place where you have to be careful. So here's another example of where data collection can lead to bias, and this is from The Economist, and it's really nice visual. They had a few others, you can go and check them out. But here what you see is Google Open Images dataset, and the resolution's not perfect, but what you can see in these two visuals, the first one is on the left-hand side, images that have male people in them, and on the right, female, and then the associated labels, and then the proportion of labels in those data sets. So you see on the very right-hand side, images labeled marriage are like way, way, way more likely to have female than male images associated with them in this data set. And you can see, for example, on the lower graph that ballet dancers are seen more frequently in images of lighter skinned than darker skinned people. And this, as you can imagine, can lead to problems in model accuracy if this is the data set that you use to train your models. And just one thing on that, like it's not all a story of big companies like Google doing bad things. Google actually recognized this as a problem, and they open sourced a place where you can actually upload images like taken from different geographical areas, exactly trying to correct for this bias. So this is another example of where you can have biases, but not biases, but just unethical behavior associated with data in general, because I'm focusing very much right now on bias in data, but there are many things that can go wrong when building a data product. And recently, as Roe v. Wade was overturned in the US, there was a bit of a panic about period tracking apps and whether or not you should feel safe tracking your period, because maybe then they could find out that you had an abortion. It turns out that that's okay, like no one is going to get in trouble via their period tracking app. But what is actually true is that a lot of these apps in the US have been fined by the FTC over the last few years for sharing this data with advertisers. So, for example, Flow is one of the biggest ones, and the notes that you take in it, they sold that to advertisers like Walmart's, like Amazon, etc. And that's just, potentially unethical behavior. So it's not just about bias. Okay, so how do you mitigate bias? The first step, I think, is identifying it and measuring it. Another step is being transparent around it, both building transparent models so you can really see where bias is introduced, but also being transparent on about which data your model was trained on, whether it could have a propensity to bias, and therefore encouraging users to treat its output in a way like that works with that and it respects that. And a third element is human-centered design, which I will also describe what that is. So how first do we measure bias? So brief review of some binary classification metrics. I'm going to focus on the binary problem here, but of course with multi-classification or other sort of machine learning problems, there are equivalents or near equivalents. So a true positive is when you predict something to be true and it is in fact true. The rest you can read. But most of the time when we're training a binary classification model, we're trying to have the highest true positive and the lowest false positive rates, and then the highest true negatives and the lowest false negative rates. So just getting back to this idea of how fairness can be different in different contexts, I want to give you this. You can peruse at your own leisure. I won't go through it in too much detail, but basically these are three different types of fairness. The first one is demographic parity. So this is if people go, or like if samples go through a classification model, the same proportion from each group should end up being predicted true. So in this instance, if you have 20 females and 80 females and 20 males apply, this should be 8 females and 2 males should be offered a position. So that's obviously quite limiting definition of fairness, but that's often what ends being applied in, for example, a college admission process. What you might be more interested in is inequality of opportunity. So assuming that there are certain numbers of qualified males and females, the same proportion of qualified males and qualified females should end up being offered a position. What's even stricter still is this notion of equalized odds, where you have equality of true positive and false positive rate across both protected groups. And you can see that each of these types of fairness might be something you want to apply in different scenarios. So think about cases where you're really optimizing for true positive rate. So when you're detecting a disease, for example, that might be something that you would consider equality of opportunity very important. There are other times where you're really focused on equalized odds. It depends on where and how you're applying your model effectively. And just one thing to say about this is there is a great tool from Google called the What If tool. And they allow you to look at the COMPASS data set, which is this data set for this model that was used to predict prisoner recidivism, which is the likelihood of a prisoner recommitting a crime once they were let out. And you could see with that model, it ended up being quite biased towards darker skinned individuals. And you can play around in their tool with different so it was a binary yes-no model, and you can play around with the threshold above which you say yes and below which you say no. And by playing around with that threshold, you get different sort of fairness rates for different protected groups. So you could really optimize it to be more fair across different groups. So I'd recommend you go check that out. So another element I mentioned is human-centered design. What is it? It's basically just keeping the human in the center to whatever you're designing. It's pretty self-explanatory. And one great resource for this is Google's People and AI guidebook. So it's produced by their peer research group. And they really start with this framework for how to build a product and questions you should ask yourself as you're building any sort of product involving data. I personally have found it so useful because often as a data scientist, I skip over a couple of these steps. I just see a problem and I try and solve it using mathematics, and I don't consider when and how should I use AI in my product. I say, oh, AI should be used everywhere. Why not? And I've found this very, very useful. And one thing they really narrow in on is exactly this problem of framing the problem. So how do you translate your user problem you're trying to solve into a problem that you give to your machine learning algorithm, or you then try and solve using data? So the first is finding the intersection of user needs and AI strengths. People get excited about AI. They say, why don't we do this? And sometimes I'm like, but is that actually a problem right now? Or is it not? Assess when to automate and when to augment. So one use of AI that I personally love is Gmail's autocomplete as you're writing your email. It really just suggests what you should write next. It doesn't automate for you. It doesn't send an email directly, which would be a bit scary, in my opinion. It sort of suggests you can easily tab, it completes, it augments your email writing process. And I think there's a lot of AI use cases out there that fail because they try to automate when they should really be augmenting, because there's still a lot of tasks we do that we enjoy and that we want to have a lot of control over. People want to have control in medical situations. It appears they still want a lot of control in driving situations. So it's something always to keep in mind. And designing and evaluate the reward function. So what is a good outcome from your model? It might just be about getting the highest accuracy. It might be also about being fair or not producing harmful content. So with generative AI, so these large language models that are producing text output, it's, for example, maybe not just whether they're good at completing text, like that's one way to score them, but also is the text that they're completing safe, harmful, or harmless, inclusive? Does it satisfy these other ethics we would like to bring to like everything that we produce in products? And then transparency. So I like this definition of transparency in AI because often we leave out the understandable. So we say transparency in AI requires an explanation of how an algorithm works. That explanation also has to be understandable, or else it's not a very useful explanation. And that means answering, what is this algorithm doing? Why is it outputting this particular decision? And how did it know how to do this? And with the EU's new regulation, etc., like this is going to be more and more something you will have to consider from a regulatory point of view. But it's also just important to be able, going back again, able to design really good reward functions. So part of transparency is simplicity. So solving the problem in the simplest way that you can then use an understandable explanation for. There are lots of tools for explainability. Some of them are only applicable to a certain class of models like SHAP and LIME or feature permutation methods. But another way to be transparent with not just people within your team, but broader set of people who might use your models are model cards. And Google, again, have great examples of model cards, and I linked the example there. But you can see it with OpenAI's models, for example. They have extensive documentation explaining what their models were trained on, what are their limitations, what are their performance on certain benchmarks, what are the problems that they have seen with them. And I think this is really great trend, and hopefully it will continue. And just because a lot of that could have sounded like dire warnings. I think it's also very exciting. Of course, all the developments in AI. And also with any problems that arise, it's also an opportunity for more technologies to emerge that help with those problems. And there have been very many over the past few years. So there are a bunch of tools that help you determine whether or not your algorithm is fair, or give you ideas of how to ensure your algorithm is fair. And those include ones from Facebook, Microsoft, the What If tool I mentioned from Google. But beyond that, there are now a lot of startups I've seen that really work with you directly to try and make sure your algorithms are fair. There are these resources and templates for model cards. And there are other sort of not fairness related, but like databloom.ai are a cool startup that allow distributed learning so that you're really not transferring data away from where it's sourced from. And in Europe, what's especially exciting, hopefully, is OpenGPTX, which is a project to build a model an EU equivalent of GPT-3 that will support more diversity in languages, and I guess hopefully be more in line with the EU's regulations. Yeah, so that was it. I'm happy to take any questions you may have, and also feel free to ask me during the break or reach out to me on LinkedIn if you want to have a follow-up discussion about any of this stuff.
Questions? Comments?
Sorry? Oh, yeah, well.
Yeah, I had a question regarding the matrices you showed. The basic doubt was like when you design a model, right? The underground evaluation data, what if that is also biased and your matrices come out good and you just deploy the model with that evaluation data? How do you even think about the variables that's going to affect your model?
Yes, so I think a lot of, I mentioned model cards, but a lot of data sets these days also have data cards describing the data set. And the first step would also, like, of course, to try and make the data set itself as fair as possible. And there are lots of interesting things out there to do it if you can't get fair data, like generating synthetic data, which is fair. You can explore things like over and under sampling certain parts of your data set. But then on the point about like whether you look at this matrix and if it's fair or not, you just go deploy. I think it's the same with model accuracy, for example. You don't look at just accuracy on one data set and deploy and say, see you later, model. Like hopefully you're monitoring it in production. You're constantly doing sense checks on the decisions it's making and building sort of a robust ML infrastructure to make sure you monitor it over time. And the other thing is, of course, I'm sure at some point you may have to retrain it. And then you also, of course, need to make sure the data set then is fair and won't lead to biases. Does that answer your question?
Yeah, like thinking about that variables is kind of difficult. Like maybe if I'm training an age prediction model, there might be a lot of variable that influence it, right? Which I might not even think about while making the data at the initial stage. So
yeah, no, that's okay. Yeah, that's a really good point. So like as an example with the like some of the fraud detection models I have built, like of course you can try and think in advance, like how might this lead to harmful bias? Like one sneaky example I came across from a model that I developed was I was using somehow like the format of email addresses a bit because it could be predictive of fraud. And the reason it could be is a lot of people who commit fraud use throwaway email addresses, and they, but then I found that penalized a lot against shoppers from a lot of very different regions, because in some regions in the world, they, like non-fraudulent shoppers may also use those kind of throwaway email addresses. And that was something I hadn't thought of at all up in advance. But I think how we discovered it in the end was doing sort of human spot checks of decisions the model was making and noticing basically, oh, this is a false positive, and what are the trends we see in those false positives, and kind of pulling those out. So yeah, maybe it's just about always human, like some level of human review of decisions from a model where the stakes are quite high, I guess. Yeah.
Thank you.
Thanks for the good presentation. I have a small question. So I believe there are models like used right away from Hugging Face. So there's this transparency and the biasness that you spoke about. So, and you also mentioned about publishing that beforehand, which is a very good suggestion. But my point is that there are companies which are using the models as it is off the shelf. I mean, do you have any suggestions for the companies like those? Like, how do they kind of, tune it or correct it, address the fairness and the biasness point?
Yeah, I guess the first step is a bit like, same with eating. Eating ethically is all about where you source your food from as well. It's like maybe building ethical models. If you're building on top of other models, making sure that where you source those models from does have that record of what is the training data and what is what are the dangers. Where that's not possible, I guess the next best thing is to try, if it's not easily available, to try find that information, which in most cases I think it is out there. Maybe it's buried in some academic papers somewhere, and just to see if there are any major red flags. And then the next step again, I guess, is really seeing, and it all depends what the stakes are and what you're doing, right? But if your algorithm is making high stakes decisions or generating high stakes output, then it would be really rolling out that model with a lot of human in the loop aspects to it, like really seeing, kind of going back to this augmenting versus automating. Like if you have an idea of automating something, beginning with augmenting and then learning from human feedback, whether it's your end user or feedback gathered from internal users or whatever, like, I didn't like this output, it was harmful, or, like one thing I've seen in some tools that use in the background, things like GPT-3, is they have a lot of feedback built in, which says, is this output good? Is it bad? Is it harmful? And that's like a third element. So for example, if GPT-3 generates output which has non-inclusive language, then they have a third sort of feedback loop for that. So maybe that's an option. Yeah. Does that answer your question? Yeah, great.
Okay, maybe a bit of a related question. So you spoke about data sets that I would just download, or a model that I would just download. But maybe I'm using my own data, and more often than not, I might not be aware of the biases to look for. Yeah, so nowadays, of course, gender bias or demographic biases might have it made it to people's awareness, but there might be other biases. And would you have an idea, or is there like a checklist of common biases I could look for, a tool that I could throw my data set at, and that would give me a flags, look for this, look for that? That would be cool.
Yes, some of those tools I mentioned, they have sort of a list of what are currently considered protected attributes. The definition I gave in the beginning, it comes from those protected attributes are as per the UN. So what they consider to be the protected attributes. One random example where I have noticed, I'm a left-handed person, and a lot of mobile apps are designed for right-handed people. And there are some that are designed for left-handed people as well, and they have left-handed modes. And that is so cool, right? Like, I think the way to get ahead of these things, like personally, I survive. I survive with the apps that are for right-handed people, but it gives me so much joy when there's a left-handed mode. So maybe it's also seeing out there what are the people on the cutting edge of like product design. What are the different user groups that they're beginning to build cool features for? Like another one I think a lot of people have started introducing is like the different light in web design, like the different sort of, I don't know what it's called, but like light shades for different screens and making them screen reader accessible, of course, and all of these things. And that's something where I think there's still lots of questions about like all sorts of difficulties people have with screen reading and with ingesting visual information, etc. How do we account for them in machine learning models as well, in the output we generate from NLP models? So maybe it's also keeping up with those trends, I guess. Does that answer your question? Or? Yeah, yeah, I guess. Yeah.
Okay. I'm coming from the side that you didn't expect, but I also want to represent online audience for them not to feel like undervalued. And so I want to ask this question starting from the beginning. Is this possible to automate fairness in the means that can we assess fairness without any human intervention? So can it be just done where automatically counting true positives, false negatives, la la la, and boom, it's fair.
So I think, and related to what you were asking, like ethics themselves, like with how we live our life, are not equal, like not shared across everybody, but they're also constantly evolving over time, and we discover new things that we then consider this is an ethic that as a community we want to live by. So I think we need to constantly, if we want to keep humans like in the center of what the ethics of our world should be, humans should always be involved in building and encoding those ethics, I think.
Yeah, I mean, you're the one automating, so you don't get from here. Rainy, your talk is so booming that the questions are not ending, so I will be the bad person who will say stop to that. I will recommend you guys to ask, over the drinks, over in the pause, because, to this beautiful lady, all the questions. And I will make you to make a little promise to our online audience that you're gonna look through the questions and maybe type a couple of words, because all the questions are actually super interesting and I am relatable to some of them, but I know to spend time on it, it's kind of unfair. So thank you for you. Little round of applause in the online. Thank you very much. And now you will hand this mic over. We will do in a self-service to a Roman from MetroRank AI, our CDO, and he will talk about his presentation, which is about fixing bias in search systems and recommender systems. And I guess at some point we will see not only you, but presentation. Yeah. So it will be especially cool.
Oh,
yes.
wine.
And welcome.
Hi. Hi. My name is Grybenikov Roman, and I'm going to talk about biases, but not really ethical biases, but more like a behavioral biases. It works. So that's me. I fix it. I need to point to the laptop. If I do it like this, it works. Okay, so I'm coming originally from academia, did some different areas of machine learning, but for the last couple of years I'm working in search and recommendations and with focus on relevancy and ranking. And right now I'm working on an open source project which is called MetroRank, which is like a learn to rank thing for mere mortals. And when you're working on the ranking and coming from e-commerce, you're focusing on a different aspect of biases. So when you're applying machine learning to humans, yes, you need to think about ethics and so on. But if you're doing it for products, maybe for some dishwasher or for a group on LinkedIn or a cat video, there's not that many ethical biases you might have. So that's another wonderful thing on working on e-commerce. So these are use cases for ranking, and ranking is around us where you have a list of something and you have some sort of an end goal to optimize. So And the most common approach I've seen in different companies, just like a YOLO thing, just sort everything by the number of clicks you have or by the number of page views or whatever. And then it's quite easy to implement. It seems that like, hey, these things which are getting a lot of clicks will get even more clicks. But there are some pros and cons on this approach, and probably you will introduce what a surprise, a bias. So items with more clicks will get even more clicks, like in capitalism, richer getting richer. And people are having some sort of behavioral biases, and they don't just go too much on the bottom of the list, but because they are lazy, and your new items are not going to make into the top first page of your search results because they just have less clicks and they don't have even a chance to get more clicks because they are not entering the first page of search results ever. There are multiple types of biases you can see in e-commerce or in some other areas which are not related to scoring and ranking people. So the first one is position bias, which is probably the one people starting to work with when they focus on biases, and usually it's the strongest one out of the whole list. There are some presentation biases when the way you present something to people affects the way they behave. Some context biases, maybe model bias when you train a machine learning model of an output of this model and you just go like a Ouroboros eating your own tail and degrading the whole experience. So we'll focus mostly on the position bias, but all of them are kind of similar from technical perspective and what you can do with them. So I personally click on first items on the list because I'm just lazy. I don't have enough time to scroll through the whole listing. But from the relevancy engineer perspective, you got to click on the first position on your search results or on recommendations or whatever. Was it done because it's relevant or because it's first? So how can you distinguish? Is it a good signal or it's just a noise? Because you always observe it together. So we did some sort of an experiment for this particular talk. So we made a movie search movie search ranking dataset with Toloka AI. Kudos for folks from Toloka for helping us to make it, because without their help, I will probably fail spectacularly. So we took top 10,000 movies from TeamDB database with titles and all that stuff. You can see the example how it looks like for the internal structure. And we used a Google Keyword Planner tool to fetch all the search queries which are usually related to these movies. So there is some sort of an API you can interact and pull this list of all the queries, which you can see it's quite small here, but you can see that for the metrics, there are Wachowskis, Animatrix, Glitch in the Matrix, and so other. People are searching together with this movie. And we did some sort of labeling through the people working on Toloka, so it was approximately 700-something labels, and 8% of them are relevant. So what we did is actually presented a query, a search results like this. Toloka actually has a proper search relevancy template if you want to do this thing for your company, and it is unbiased. So that's how it looks like on the left. So you have a product and a query, and you can say, is it relevant or not? There is no information about position, so it's just a yes or no answer. For us, we wanted to shoot ourselves in the foot, so it's instead of that doing it properly, we showed something with explicit item ordering. And then by doing an explicit item ordering in this list, we introduced a position bias there, but with a trick. So the search results were not ranked by the text relevancy by BM25, but they were just top something relevant, but shuffled. So the position of the probably relevant movie was somewhere, and it was independent from relevancy. So you might expect that your the graph, this graph of probability by position should be like a flat. So because a relevant movie can be anywhere, you shuffle the results, but still people are clicking more frequently on top items and then on the bottom items because just they are too lazy to scroll. We did some data cleaning, and the way you can clean it is still the same. So it's from my observation, because not all the queries are very exact, so it can be quite inexact, or just with multiple search results matching for your query, and you're just more often clicking on the top matching results than on bottom matching results because just position bias. That's because we're people. It's not only about position. So if you represent something in a grid, you expect that people scan it from left to right, from top to bottom, if they read from left to right, from top to bottom. But usually it's some sort of, can be in a very obscure way. And due to this obscure way, you might notice that this item, like number 5, might get more clicks than the item number 4, just because it's below. And people are scanning search results in this way. And for the presentation bias in this particular data set, what we also observe, so there is a segment of desktop users with 3 columns on the search results with the different types of layouts. So if you go for the data set, I will give you a link later. You can see that there is some like a drop after an item number 3 here, like the first row, you can see it instantly, and then something else. And if you have multiple search results which are relevant to your query, you might just say, okay, that's it. I don't want to go down to the list because I already found it. And for my own observation is that bias in search depends on the function of your search or of your recommendations. Is that for this particular case of movie search, all the queries were very precise, and this kind of a navigational queries. You already know what you're looking for. You're looking for the matrix, you're looking for your cat food. And if you're looking for cat food, it doesn't really matter on which position your favorite cat food is ranked, you will just find it and buy. And if you're doing a discovery thing, you have no idea what you're looking for. Like you went on Zalando, typed jeans, there are 20,000 different jeans, and you won't be able to scroll even for the first 5 pages. You will just go from up to down, first 5, and call it a day. So in practice, if you're trying to mitigate bias or de-bias it, it's kind of complicated because you're rarely observing it separately from the relevancy. You observe it together, so it's the same data set, but we just not shuffled it, but sorted by the text relevancy, by BM25, and you can see that, okay, the results which should be ranked first, it's usually clicked more frequently because there is probably a correlation, high correlation between the text relevancy and the click probability. That's the point of the search. But not always. So from the perspective of a relevancy engineer, a person working with the ranking, the whole problem of optimizing your ranking is just, if you're not really comfortable with things like learn to rank and lambda mart, with just a short introduction of this idea of ranking, is that it's just like a classic. So you have an implicit feedback coming from your users. You have a query, the user was presented this list of results, the user clicked on the item 3, and we assume that this item is relevant to the query because user decided that it's relevant. That's noisy, there is a lot of subjective information there, but still you can have this data almost for free, and you can do something about that. You can use item metadata as ranking factors. If you are in e-commerce, it can be price or maybe text relevancy information between the title of item and between the search query. And you use a very specific loss function. So in classical machine learning, its loss function is not sensitive to the position of the item. But if we're working with ranking, you might feel that the error made on the beginning of the list is not the same as error made on the end of the list. So for example, you swap first and second search results. Will it matter much? Not really, because it's almost the same. But what if you swap first and last? Yes, probably it will matter, because your overall search experience will degrade because there is an irrelevant item on the top. So there are some different types of loss functions, and they are pair-wise, so it's more about a pair of items in your ranking. And the most popular is in DCG, which are we going to talk about and mention a bit. And not all clicks are made equal. So from the lambda mart perspective, you can, from the learn to rank perspective, all your information about the implicit feedback is unfolded into some sort of a table or data. So, okay, we were presented with these 4 items. We have all this information about the ranking, and we know that first items were examined but not clicked, and the third one is clicked, so we can assume that it's like a positive and negative labels. But observing this thing from this relevancy perspective, you might and all our feedback information. So we know that the click happened on the first position is not the same as click happened on the third position. And so they are like affected by bias. And if we can estimate bias, like here, we have some sort of observed relevancy, and we can just weight it by the bias. So we know that click on the first position is highly affected. We know how high it is, how strong is this influence of bias, and we just offset the importance of this click a bit lower. So, but the only thing we need to do is just to estimate this type of bias. There are different approaches to do this, but the most probably old and popular one is called inverse propensity weighting. So you shuffle a short segment of your traffic and see how people interact with the same product within the same context, but on a different position. So just an example from this paper is that's how people usually click on different positions in general, like click-through rate per position. So everyone is clicking somewhere at the beginning. But the second one is click-through rate of the same item within the same context, but just on a different position. So it's the same search query, the same search results, the same product, but just on a first position, it gets much more clicks than on a 15th position because of this position bias. But if you shuffle it, you can reconstruct this information about how strong bias is per position, and then just offset by it. So that's how it looks like. The same socks, same query, different position, and different amount of clicks because of the position bias. The product is the same. You aggregate it per product, per queries, and then you will get some sort of decaying graph of bias. And you just weight it and call it a day. Will it work? Probably yes, but the problem is that shuffling affects your business metrics. So that's a slide from Mises conference, and like this shuffling of search results gives like a significant drop in conversion and average order value. So at the end, this experiment can be quite costly. So it's not like you are paying for that, you're just getting less sales, and it might be quite expensive to do this experiment. There are different ways to make it less costly and not just shuffle everything, but shuffle top 3, for example, items, because they are most heavily affected by bias. So we don't need to shuffle everything. We just need to shuffle something on the top. You can do not the complete shuffling of small segment of traffic, but just swaps of items in the whole traffic. Or if you're running multiple A/B tests, you can just exploit it as is. So you don't need to shuffle. You already have it happening organically due to different A/B test ranking models you have. So the same items within the same context are still ranked on different positions. Not because of you are shuffling the traffic, but because of some other reasons, and you do some other experiments. But we can go further. Why it's 2023 almost, and we're using statistics to estimate bias. Why don't we just use a machine learning model to estimate this type of bias? So technically, bias is trying to estimate this bias. You need just to predict the click probability on different positions based on only biased factors. Like you're trying to predict probability based on item position, item cost, item popularity, but without any context on the ranking you have. So in the perfect, if you use only the position as this factor, you will just converge to the inverse propensity weighting actually, but you can mix together some other factors which are not leaking the context inside of this machine learning model. So you can do this to predict the bias, but what can you do with this prediction? As we suggested, you might do weighting by this bias, or you can do some sampling, but both of these approaches have some pros and cons. For sampling, it's probably you're just breaking your data set. It's not the same as will be running on your production. With the weighting, I have like a cool story about how we implemented inverse propensity weighting and how we shoot ourselves in the foot. So we did our perfect inverse propensity weighting ranking, and some of the e-commerce stores we were working with started complaining that for some of the search queries, or maybe some of the collections, not all of them, like 5%, so it's not significant, too many unpopular items went on the top. We started to dig deeper and found that our weighted ranking was an inverse of non-weighted ranking. So it started just to swap it for some reason. Why? Because our training data was biased towards the number of clicks. So the machine learning model, which was used to rank these items, preferred the popular items to be on the top of the list, as our propensity weighting weights it from top to bottom. So the lower the click, the more important it is. And the lower the click, the lower the popularity, the number of clicks. So it assumed quite validly that, okay, so the lower the number of clicks, the better is the relevancy. So it just swapped it, inverted it, and called it a day, because what it was asked to do it, but like implicitly, and we leaked a bias there, probably multiple biases at once, and shoot ourselves in the foot. So from the inverse propensity weighting perspective, the bias is not constant across the whole store, across your website. It can be dependent on the context, dependent on the query, maybe on some list of genes, it can be high. On a list on some details for autos, it can be low. So you also need to, and you need to just spend more time estimating it, and maybe we can just instead mix it into the model, so your model can be bias aware and learn bias, relevancy, and how bias influences the relevancy at the same time. I always like to quote this PAL, position-aware paper, which is not the best way to do position-aware learning, but it's the most cited one probably. So the idea is that you have a couple of ranking factors, couple of factors in your machine learning model, maybe not about the ranking itself. Some of them are biased, some of them are non-biased. You use the whole data set for training, so it can find dependencies between the data. But on the inference side, you just fix the biased factors by some sort of a constant. So in the case of position, you just put something in the middle of the list, like, 5. And then from the model perspective, it will look like that all your items you're asking to rank are actually on the same position. And it's kind of just offsetting the bias in a way which is quite simple and applicable to not only ranking, but some other machine learning models. There is also some sort of a demo which we did with MetaRank, this ranking thing with the learn to rank for mere mortals. So we have a movie recommender running on our demo website, and it's using a data set we also collected also from Toloka, surprisingly. And it's like movie lens, but with the ranking information. So we know what was presented to people and how they were interacting with. So people labeled favorite movies, but not like in a proper way you label movies, like, do you like this movie, yes or no? But choose favorite movies within this topic from this list. And this list is actually quite an important point because you can take the position information from there. MetaRank is just a ranker, so it's usually for search, it integrates with something. For recommendations, we pre-computed everything with the ALS because why not? And we just plugged, MetaRank support this PAL with just 3 lines of code. And if why we choose PAL and not inverse propensity weighting or whatever else, because it's kind of shuffling can be costly from the business perspective. If you're learning bias together with your ranking model, it can also learn some sort of a context. And at the end, it can be also adapted not only to position bias, but you can also apply it to some other types of biases like presentation bias. You can some sort of introduce a position in a grid if you're trying to use the grid information, or just make it aware of click-through rates or whatever. And from the results perspective, we found that introducing this position bias improves, like in DCG, slightly for 1%. Is it good? It's not the best thing you can do, but still 1% for free is always nice. So should you really debias your data in your rankings? Usually it depends. So if you have a strong navigational, strong discovery function in your ranking, probably yes. If it's not, and more about navigation, probably no. But still, you can always evaluate, just to shuffle a small subset of the data and see how people click on the same results and how behavior of people changes. You can also just see other papers which are based on PAL and see how it can be improved. But still, it's quite easy to implement. It took me like half of the day with writing the documentation, so that's it. That's the whole talk. The tool I was using for this demos is MetaRank. You can hang out with us on Slack. The data set for this movie search is on GitHub. So it's open source and you can play with it. The rank lens is also on GitHub and PAL paper. So that's it. Questions?
Okay, I wanted to start with online, but offline is faster. So what can I do? Okay, who was like, I'm sorry, I noticed you because of the hoodie. So I guess now you will be, yeah, you did the right thing.
Thank you. My question is about the position-aware learning. I'm not sure if they present this in the paper, but how does this approach compare to the one where you could just remove biased features from the model?
Maybe it depends on the features, but still, how can you remove position information from the model? Then I mean that there's the clicks on the first positions are not giving you much information, so you just let the model decide what is important and what is not important from the learning perspective, and not trying to do it explicitly with weighting. So it's not about the machine learning features. Probably you shouldn't use position bias position information as a feature at all in general. But you can just hint the model how important and how less important clicks on the first position. So that's the point.
Okay, I think I'll go deeper into the paper. Maybe there are some interesting notes with this regard. Thanks.
There is also, there is also a talk from the latest Haystack conference from some person from Otto. They're doing a bit deeper dive on this bias-aware learning. So you can watch that. Or I can send you a link if you come after the talk.
So this is related to the bias-aware learning part. So when you have a data set and you actually change the order, for example, your recommendations as you described at one stage, different types of people may actually react differently. So you may have an age bias, for example, that they would actually have a different, let's say, ranking for you to how to change the importance with that. There's also the kind of question that I have in the sense, have you look at individual people, and if you look at those rankings from looking individual people, they actually give you a type of a psychological profile of how they behave by figuring out whether they are picking the first in a row or the second in a row and how they do that. So it actually contains hidden personal information that you can classify people. So this is a kind of a GDPR thingy coming on out of the system, and you can actually relate it to psychological properties when you do that.
But that's wonderful when you rank items and not people.
Yeah, but you rank items, but ranking the items actually define how people behave. I give you an example in the way in calls. If you make calls and you rank the metadata for that, so that's just the metadata is very easy thing that you answer a call and then you spend a certain time in the call. Now, if somebody calls you and you spend a long time in the phone, or then you compare it to somebody who is usually kind of spending more time than they call themselves. So that's actually defines whether you're an extrovert or introvert. It's only metadata, very high level, and you can actually psychologically profile people for that. Yeah. So this is fancy tool because now you actually, if you start changing the position on it, you actually make a psychological experiment on people.
Probably.
So this is leaking in a funny way on the system. So is there any remedy for that?
Don't try to estimate extravertal or just don't do many features which are very personal. So just for my personal experience working in e-commerce for small and medium merchants, there are not that many people coming for the second time. So you don't have a vast history of click-throughs. So it's just 1, 2, 3 interactions happening just right now. And
your answer really your eyes.
Sorry?
Your answer really is that you shut your eyes. So
yeah, so just not trying to do this cross-device or more complicated tracking and just use only session information. So you clicked on this course because of clicked on this course, you might interested in that course. It's not related to you personally because there are no ranking features related to you, but just some sort of an aggregations. But if you go deeper with deep neural networks, who knows what goes on there? Maybe there is a special cluster, for introverts.
Hey, how are you? I had a question. How is presentation accounted for in some of these ranking, or if there's any knowledge about that? For instance, if you're on a mobile phone or different size browsers, how the presentation would change, and how kind of you can alleviate that in any way, shape, or form.
So you can estimate this bias also, just separately for different segments, or you can just, so usually it is. So for the data set, this movie search one, there is also an information about the platform you did this evaluation. So it's desktop or mobile. And if you draw this probability of click per position, you can see that it's different for desktop people and mobile people. For some reason, mobile people click more. I have no idea why, but it's just decaying in a bit different angle. What to do? Probably maybe separate model, maybe just introduce it as a biased feature. Who knows? So you just usually need to try different approaches.
Okay, now I will have a very legit reason to give you an ability to talk with Roma more, because we'll have now a short break to before the panel discussion, we want to freshen up and everything. And I suggest you to attack Roman fully and ask him everything, because yes, he did a very intense talk with a lot of information, and actually I can understand how many questions you want to ask. I'm so sorry for the people who I didn't give the ability right now, but catch him and you'll succeed. And in 10 minutes, we'll start our panel discussion, where I'll try to introduce everybody to ability to firstly listen to the questions and how they answered, and then start with your own funniest one or the stupidest one, or however you want. But now I'll suggest to rest a little bit. Let's do it for 10 minutes. And thank you very much, Roman. Also one, yes.
There is food there.
So guys, we're starting in 2 minutes, especially the people who are in the panel discussion, please sit. I need somebody to talk to. That knows only Valia, so you see, as I remember, it was...
I remember it was...
Yes, you were sitting next to me. Then I don't remember anything, so let me... we'll just arrange randomly. Here is your seat, here is yours. Yes. And then I, of course, will rearrange you like in a game of cheers, because the Valia was the holder of the knowledge. How everybody... Yes. No. You will start running around, and I'll take away one cheer, and the one speaker will go. Where is Raman? We lost him. He's here. Give me a second, I'll return. No. Okay. No. It's nice. We changed the order, and now I'm in the center, so I'm feeling more involved, actually. So I guess I will ask. Give me a second. I will do the one thing. So that, can you give me an honor and start carrying mic around the speakers, because I just...
Sure, yes.
I don't want to stand up each time.
Sure. Yeah.
Okay, so I suppose I will do 2 things. I will firstly tell you to get very comfortable, and secondly, like at 20 minutes after, we'll try to start conversation with the speakers, let everybody speak, and then we'll just move to audience, so you will be also free to ask some questions to the speakers, or even answer on some topic which you feel very proficient in biases, because I wouldn't say that, like, for example, there is not as proficient person in auditory who can beat all of us. Guys, don't get offended. I mean, you're the best of the best. So, like, I want to start asking questions which bother me. I have this, like, privilege, I guess. So the first question that I want to ask, and I guess everybody of you can start in each order, but I want everybody of you to give, like, a few intakes on that. Do you think, like, we know that biases are kind of, like, most of them are rising, they're historical, because firstly, the data that we are scraping from internet, if we're talking about the fairness in AI and the data that we're learning our models on, it's pretty much like based on some historical biases, maybe gender or like age or something biases that are arising from some systems which were in the society. And also behavioral biases are also based on kind of historical data, because some behavior arises with a new technology, like you invent search engine, boom, bias. So what do you think, like, how maybe we don't need even fight historical biases because they will go away naturally with history changing and the society fixing itself all of these problems? Or you're thinking that these historical biases we also should continue to tackle and to fix? Or we're just going to new biases and we're like leaving it behind and not thinking about it? I like how Florian looked at me and nodded, so I knew that he has something to say.
Oh, let's validate this, but okay. So my name is Florian. I'm working for Gina AI. It's an open source company, neural search. We do content-based search. Just that you know, I'm not an expert in ethics or or not an historian.
But expert in search, so at least like we're covering here the different aspects of the behavioral biases, aren't we?
Yes. So so regarding your question, I think yeah, like changing some historical data also has a bit the threat of acting like the past would have been different. So maybe also forgetting some things that happened in the past. For instance, when you use some open AI generated tools like DALL-E 2 to generate images, then they extend the prompt to make it gender conform and consider different ethics. And depending on what you generate, if it's like you generate a historic graphic of something where you know it's only one ethnicity or only one gender, and then it biases this towards this, and it's like even going in the wrong direction, where you act like on historic pictures there have been equity in all sense, but actually it wasn't. So it can go into a totally different direction. And that's why very often I think fighting a bias can also, you should take really care if you're not actually adding another bias and even make it worse.
Perhaps from my side a little bit to add on that. I think as you had also mentioned in your presentation, it's quite important to first of all be able to measure the problem and then to be somehow transparent about that. This is already, I would say, quite an important step. And then defining what we are actually optimizing for that particular use case, I would say is at least important to not make things worse, because if you already at least are aware that you are applying, let's say, equality of demographics or something along those lines, then at least you are not making the trends that already exist on historic data and in the society worse. Hopefully, you are doing more than that, depending also on the use case. So if you go towards a more, let's say, strict definitions, equality of opportunity or odds or outcomes, the more that you actually are aiming to change the status quo, the more, let's say, strict you need to be on the definitions that you're applying. But already the very basic on historic data, depending on the use case, I would say, is to not make the situation worse. So it's important to measure and at least apply some definition of equality. Now, depending on the use case, depends on, as we discussed a little bit in the presentations today, it's a different thing if you are somehow evaluating humans, it's a different thing if you are just ranking items for e-commerce. The, let's say, implications and severity of impact from a human perspective is very different. But I would say generally it's quite important to measure and be transparent at the very least. So that I would say is where the baseline for me is. But yeah, then as we are hopefully not making situation worse and society improves, we're applying critical, let's say, safeguards for the use cases where this really is required, then we can also over time improve it.
First, directly on that, like DALI example you gave, which I think is a very good point, I would just say that what's very important is to consider generalization versus specificity. So we always get into trouble with bias when we take something specific and generalize it. And I think if you send a general prompt to DALI, which is like a historical figure, XYZ, then I'm not so sad if they sort of reflect equal genders or ethnicities. I think if you prompted DALI, show me like a cartoon image of King Henry VIII, and they misrepresented that I would have a bigger problem with. So I think it's about teaching people to be specific. So if you Google ballet dancer, maybe it misrepresents history to show a diverse set of ballet dancers, but it is actually like they're still capable of Googling for a particular ethnicity ballet dancer if you so want such an image. So that's kind of one thing I think about that. And then to your question about, is it enough to just assume that like history will pass out of our models and our behavior? Like, I think no, because we have to, it's just like if you have children, you have to demonstrate, you have to show and not tell. And if we want to train the data that is being used or change the data that will be used for future models, we have to live differently, we have to talk differently, and we'll have to continue doing that to reflect evolving like ethics. So it's like one, just a personal anecdote for me is that I, for a long time when I was younger, was in a habit of automatically asking people, oh, do you have a boyfriend or do you have a girlfriend? And I made a conscious effort to change that to asking, do you have a partner? And it was something I had to consciously do. It didn't happen automatically in my case. Maybe ideally it would, but it doesn't. And I think that's a positive change. And I think we have to keep doing that if we want to make sure that we don't keep ending up with different sort of biases in the future.
I actually want to address the next question to Ramon too, because it came into my head and I think it will perfectly fit. But firstly, I'm very interested on the part that you said about the models, biases, and algorithms, like about children. So we're still like kind of this position to the technology, like something that we train like consciously. So we will talk about that more. So, okay, we understand that there is a historical data and we need to fix it, but every day not every day, but we are inviting something new. Each of us is kind of working in some industry, pretty much mostly, I guess, IT. And some of here, for example, Raman is CTO of a new product. So it's, yeah, I made it. But really, you're inviting a new product, you're inviting a new thing. And is there any possibility, like from your perspective, guys, as inviting a new products, new features, and new ideas, start making it from the beginning without bias? Because you can apply the old mechanisms and they probably will detect something, but how to, like, do you have any personal idea how to try to ensure that you're not introducing a new one? Because search came, like position bias came, recommendations came, choice overload came. Whatever. Like, I'm very interested. Do you think of any technique before like giving something to the world, or you're like, okay, I will care about this later?
I guess some of the biases, like behavioral ones and position ones, like position bias, is not specific to humans. So for example, imagine a dinosaur and 10 pieces of meat, and dinosaur will need to choose one. Will it fairly evaluate all 10? Or just choose the first one looking
Depends
nice?
on the hunger. Depends on the hunger.
Depends, but probably it will be biased by position. It's not e-commerce, but it's dinosaurs, but still not specific to humans in general. So I don't think that some of these behavioral biases will go away.
So maybe we should do like, so here we're coming kind of to a question that biases are completely human thing or no? Like, what do you think, guys? You work like with the IT structures. You, Florian, for example, invented in Gina now, like these searches. Do you think that bias is only human thing, or they're also like system-wise arising?
So what is the other thing, the non-human thing?
Are biases arising only from humans, or it's also like the models that we are using, or maybe hardware that we are using, or it's hopeless because whatever human invents, it introduces new biases. So you're like kind of stuck in the infinite loop of inventing and fixing.
Yeah, so I don't think that there's some hardware bias or bias in the models. So models are so general. So, and with the transformers, we make them even more general and actually remove all kind of bias. And therefore, I think it's purely data related. Yeah.
So technically, like, now I'm thinking like we were talking about that we're training the models and like training hardware like a children. So we're introducing to them biases like to our children. So recently it's a lot of talks about the consciousness of AI. I mean, not recently, we're talking about it like each 10 years from the beginning. And with these big models, which were like GPT-3, chat, these like DALL-E 2, you're looking at them and you're like, hey, conscious AI is getting closer, huh? No? And then one of the biggest problems of these models are biases again. So maybe one of you have an opinion that we should change an approach of like doing this. Maybe these mechanisms should be made with AutoML and like robots make robots. Can we get rid of this bias like with humans, or it's just like waiting until robots start doing robots and then it will come to the perfection? Anybody who wants to do and take on this crazy idea?
I mean, I can try for that. Though, yeah, obviously, I'm a little bit further away from the technical discussion, so I will a little bit be slightly more philosophical for this question. I would say that these machines have also, in order to work, they need to be trained on something. As long as we are talking about systematic ways, machine learning algorithms, they need to be trained on some kind of data. And inherently, these data are generated either by natural processes or more typically by humans. So the possibility that there is somehow bias in the beginning of the loop of learning and optimizing is probably quite high. But then the second part of that is not all biases are also equally bad, because eventually bias is just a heuristic. And some cases, a heuristic, like in your example with the dinosaur that I quite liked, a heuristic, it's okay. It's an oversimplification of a complex system. So you are making a decision somehow a little bit easier, and this is in some cases it's quite okay. When it becomes a problem is when it affects the life of humans, I would say, on a personal level, and especially the more, let's say, the impact is higher, the more important it is there to invest time and make it as good as possible and as let's say safeguarded as possible. So also the amount of energy, focus, attention, reward mechanisms that we would apply to different types of use cases in order to solve these types of problems is quite different. But going back to, let's say, the original premise of having it completely automated with machines and algorithms, first of all, I don't think that it will solve the problem. Honestly, I also think that we are really quite far away from that still. So it's not probably happening in the next couple of years or 10 or so. But the more that we are, as humans, trying to at least address the more problematic cases, the better it will be for us, I would say, in the mid to longer run.
Yeah, so I agree. It's far away. And what I also think is, getting back to framing the problem, like what has to kick off this whole process is some objective that we give. For now, we're still in control, quote unquote. So like it's all about what objective we give it to work towards, because that's how it works right now. It's not developing necessarily its own objectives in a broader sense. But one kind of thought that I always refer back to is, in our current system of capitalism, like if we're building things that are objective towards capitalism, and there's one thing that comes up around automating jobs, is for the system to work, you still need people to buy things, as depressing as that sounds. And for people to buy things, you need them to have desire to buy things, and you need them to sustain this like economy as we have it. And I think potentially AI could develop appetites at some point, but it's certainly like there's no appetite there. So what are we doing all this for? Right now we're doing it to serve like products to people in a way. And as long as that's the case, like people need to have jobs, they need to have appetites, or otherwise everything falls apart. So maybe kind of bleak, but I think it's also a silver lining in terms of AI is taking over the world or whatever.
I actually like start thinking that like we are, like, at least in this committee, somebody with like a position which has a word like data in it, like data scientist or like CTO data somewhere, I'm sorry, Raman, or like, like, you know, so the technical people. And we're usually the one who fixing biases in the systems, because they're like, I mean, also there are like other people fixing biases in the other, but we're talking about the AI biases. But it sounds very philosophical and very psychological. And like starting again our line of the questions, and here I actually want everybody of you to give an intake. Should you study psychology and philosophy to fix that? Or is it just a common sense? Or is actually maybe a problem of all of the systems and AI and development just because we're not studying the field of psychology and philosophy, and we are just not getting that it's right here and it's easy fixable, we just know the area? And yeah, Roman, you start please because you knew about this behavioral bias of position. Where did you find out about that?
My take on the problem of ethics in AI is that it's some sort of a spectrum between being fair and profits. So before just discussing how fair should we be with AI, you should, as a business, answer this question for yourself. Like, what do you want? Being fair, or like being nice, or being rich, or in the sense of profits, it can be short-term profits or maybe long-term profits. It's also important. And for some companies, it can be important just to push short-term profits and just let it burn afterwards. We don't care. And then from this perspective, work on that. So we technical people usually don't really go there. So we usually got our got some sort of an input from some other management people, like, okay, please remove this bias, or okay, please don't remove this bias, please. And so it's like a hard thing to do, but probably it's not really technical.
So when building a product, we usually do MVP, like everyone. And then we just check if it's good search results. So this is basically, you were also asking, do we care about bias in the first iteration? I think first iteration is just, it should work. It should be possible to integrate into this other system, and it should give good search results. And then step after step, we discover what good search results actually mean, because usually our clients also don't know, or they cannot really express in the first place. Only when they see it, then they see, no, by the way, this is also not a good search result. So you should also put this out. This is kind of a bias or something. So for instance, we're working recently with company together. They have a website where you can find animations for web developers. And then all of these web animations, it's just some short animation of 5 seconds, and they should be found by search query. So user type in some text, and then you find this animation, and you don't have any additional information there in this animation. So you have to search from text to image, and as you know, nowadays with clip models, you can do embed the text into vector, and then also all the frames of the short video animation to vectors, and then make your nearest neighbor search in the vector space. And interestingly, we face this typographic attacks known by Clip. So this is a very popular bias Clip has, that it pays a lot of attention on the label shown on the image. So it's basically doing OCR, but also cannot do differently. So there's a famous example where you have the apple, and then there is a label on it, so on the photo, with the name iPod. And then the model thinks it's an iPod. So it cannot see the apple anymore, just because of the text handwritten, something small somewhere. And where we only found out that way. So there was no, or there must be ways for us finding out before. But the most efficient way was just deploying something, give it to them, and then they say, no, this is a bias. If someone searches for loading, they don't expect the word loading. They expect the loading bar or the spinning circle. And yeah, then the next iteration, now we work on making this model blind. So you can solve this bias by deactivating some neurons in the model responsible for text recognition, and also some other tricks, but yeah, I'm diverging here.
Yeah, largely I actually agree. Generally, it is quite natural that you have an iterative process, because also consider what ML is actually doing in at least most of the cases to begin with. It is replacing all the systems that can be just statistics and rules. So you would have a rule that would decide how we moderate users in a certain, let's say, e-commerce platform, or a set of rules. Then you will replace it with a machine learning model. And generally, you would also have probably even more bias in the previous, let's say, iteration of this use case. The thing is that as we are increasing the sophistication, increasing the complexity, it is becoming more and more necessary to be able to measure and be transparent. So I would say it is quite natural that the process is iterative and it is not solved in one step. That is not necessarily a bad thing. Perhaps where I would put an asterisk is in use cases where the impact is really, really high on human life, let's say deciding about a loan or automatically screening CVs of people, or even use cases that can potentially have even more implications about people. There I would be a bit more careful to be as fair as possible from the beginning. And if not, I would even challenge if these use cases need to be automated before we are, let's say, somehow ready to do it in a fair way. But for the majority of the use cases, it is actually quite okay to be iterative and improve over time. And this is quite natural for me.
Yeah, I think you put it really well. I think a lot of the time there's existing biases and we're already improving over them. And the most thing is being transparent. I don't think we all should rush off and do necessarily ethics masters or whatever, although it'd be super interesting. But I do think everybody has a certain, I mean, this is more personal ethics thing, but it's a bit like Severance, if you all know the TV show. I don't think your work should be completely distinct from the rest of your life. And I think if you have ethics that you believe in your personal life, ideally, not everyone has a choice, but you can choose to work for a company and build a product that reflects those ethics. And they don't need to be ones shared by everybody, but just, I do think that makes your work more also valuable if the product you build reflects your own ethics. But I don't think it's up to just to the technical people. I think most tech companies now work with cross-functional teams, and product often involves a lot of user testing and user research. I know Facebook are doing kind of cool things, although I guess they don't do much cool anymore, but this is one cool thing they do, is they source a lot of their users and they form sort of panels out of them, and they ask them to vote on their own content moderation policies. So they really source from the public ideas. So I don't think it should be just technical people. I think everybody should be involved in the process, but I think it can also be technical people as well.
Okay, actually it gives me a lot of thought of maybe I myself feel I need to study ethics a little bit, because still you need to understand what you're working for. If you're advocating for the clean data and everything, you need to understand what is fairness and what is cleanness. And when it's super subjective, it ends up, I think, not very good. We need to generalize the fairness to some extent level. But I am actually very interested now for the audience, not to make you guys feel that we're overpowering here. We're the fair and square, and you're sitting here and hearing what are the biases are and not. So I want to ask you, are you caring about this? When you're using a search engine, do you feel that output is biased when you're using an app? Grania gave an example with right and left-handed apps. That's a good example. I can talk about my own example of a bias. When you're coming to a restaurant and there is a huge, huge menu, pizza, sushi, kebab, Indian, Russian, Georgian, you're Jesus Christ, and you're going home drinking a coffee because it's a choice overload. Literally, it's a bias of the human being. You prefer butter, more choices, but it actually gives so many costs on the selection that you're just you can't select, and that's why e-com sometimes fail with recommendation systems. So from your perspective, can anybody tell about the stories when they felt how bias from the applications were coming into their life and it actually bothered you? Maybe with search, maybe with something else, maybe with trackers, maybe with deliveries, maybe with something else.
It's a long throw.
Oh my God. Yes. Woo. Okay, it's coming.
What is this actually? Okay. So yeah, the thing that bothered me most,
You covered it. You speak into it.
sorry.
I mean,
So sorry. The thing that bothered me the most is so how much Google or any other companies know about me, right? It's not biased, but the thing is the data collection has always bothered me so much. For example, I have tried many things. For example, turning off microphone access and all these things. But even if somehow they manage and they find it like, and the next day or two,
yeah, Big
whatever
Brother
was in
is
my
watching
mind,
you, huh?
yeah, it comes back. But yeah, slightly off the topic, but
I know that it's kind of being also can be connected to bias because the systems are built on the idea that they need to use your personal data to improve recommendations, but there are like two models of improving recommendation, contextual one and personal one. And contextual one works actually pretty good. If you're searching for it, you're getting it. So yeah, it's actually also a bias thing, or maybe you guys don't agree with me. No, everybody agrees with me today. That's a good day. I like it. So what about choice overload? Tell me, anybody. What do you prefer if you're coming to some selection, some recommendation platform? Let's do a survey for our friends from ecom. You're coming to an ecom platform and you're searching for a jeans and you have the recommendation of jeans. What do you want to see? Is there a person who can definitely tell which jeans they're buying? Just raise a hand. Like, first idea in. Jesus Christ, nobody knows how to buy jeans. We can make money on it. Yeah, okay. So like with choice overload, I think it's also sometimes a problem of just a behavioral bias that we can easily deal with because it's like, oh my God, I'm sorry, I'm so invested in the speed of throwing. So yeah, but since we don't even recognize the biases in our life, as you see, like people here maybe are getting like shy and tired, but in general, I think I'm getting so tired in the life that I don't see a biases mostly. Maybe we should stop caring. Maybe we're like sitting here all good, talking about it, and we're like, yeah, bias, it should be fixed. But I mean, people just worried about how it works, and yet maybe we should leave them on the first position, the most clickable link, and just make a lot of money from it. What do you think? Or ethics is like about biases is much more than just like it's very harmful. What do you think? Is it harmful or not to caring or not caring about the fairness and biases?
I mean, sort of a random example I give is Virginia Woolf's book, A Room of One's Own, which I'd highly recommend reading if you haven't. And it's a personal essay about her experience as a female novelist at the beginning of the century. And she makes the point really well and more articulately than I can, but that it's not just that she was seen as unusual as a female novelist. It was that the imagination of the world had not grown to like her experience or a female novelist. So it was about, it didn't just impact her lived life, it was the world's imagination. And I think the same about like bias, just because you don't see it doesn't mean it's not there. And our imagination maybe doesn't cover yet. And I mean, everyone can look around the world right now and see a lot of harm being done one way or another. And a lot of that harm is in some part due to bias. Not all of it, of course, there's other things going on. I mean, you know, we could talk about bias towards certain animals on the planet, for example. Like there's lots of harm being enacted in the world. So I think we should be imaginative about what part of that comes from bias and where it comes from and how we can minimize it.
You.
To be honest, I completely agree, actually. So I would say for the use cases where humans are affected, definitely we need to put the bar higher. And I liked really the way that you phrased that our imagination might not even be there as a society in some of these topics. So fully agree with that. But even on inside codes, the more trivial use cases like the ones that you discussed about, there it might be less of an actual ethical problem to some extent. But fairness is even important to the sustainability of the marketplace, I would argue, because if you are not fair and you are biased, eventually you're somehow in some sense less efficient, and that means that your sustainability as a marketplace, at least to some extent, suffers. So it is, even for these cases, I would say arguably important to start solving the problem. The urgency as a society is obviously much lower than the cases where humans are affected. But yeah, even there, I would argue that there is reason to do it.
So it's like bias connected to reputation to some extent, because you're making a bias and you're losing the reputation. Yeah, it makes actually a lot of sense, I think. So I would say beautifully wraps up that we need to care about this, and I actually think that it's still like, can I say that ethics in AI, it's at the same time a very long discussed topic, but each time it's new. Like I feel it's like this, because you introduce a new model, it's becoming new from the beginning. So I really like want each of you guys, except like the just enjoying this evening as much as possible, just start thinking with implementing new things, how you can at least lower the layer of unfairness from not only ethical, but also from the technical side, because it distributes more and more through the internet, through the technology, and it stays for a long time. Like, as you see, historical data of 200 years are arising in biases in our models now. Who could have guessed? So I was super happy to talk with all of you. I am super happy. I'm very sorry for the audience that I asked these questions about genes. I know how they're bothering at the 9 p.m. So I really want you to just enjoy the rest of the evening, talk to our amazing speakers and our amazing attendees of the panel. I'm very happy to talk to you today. Talk to organizers and maybe come to speak to them and give like another successful event. Eat our food. We have a big amount of it left and now we don't know what to do with it. And I don't know, just enjoy everything. And oh my God, I got busted. Excuse me, I'm trying to read the message. So really, I'm sorry, I set up such a mood to go and chill, but now I need to read a question from online, so 1 millisecond please. I completely feel okay, so related to the you see, mood gun. Regulations questions, how far does the upcoming AI Act from the European Commission go to incentivizing companies to care about bias? In your opinion, do they go far enough? My question could be answered by anyone, but mainly directed towards Grania. So Grania, you're the victim here.
Yeah, I don't know enough about it to really say that much beyond. I think, to me, the biggest question is not whether it goes far enough or not. More, has it been structured in a way to incentivize, as you mentioned? I think I worked, as I mentioned, in fintech for quite some time, and a lot of the regulation there does not incentivize anything. It just sort of terrorizes. And I think that's a little just the nature of how the regulation is enforced and enacted. And it's often enforced by people who are not familiar with AI or ML. So I am more curious to see how it will be carried out and whether that will be done in a reasonable way. Yeah, I don't know that answer.
Okay, I am very happy that like you were the victim, because I completely slipped off the, but it was a very nice answer, guys. Relax, enjoy. The one thing that I want to say, at the beginning we said that the questions will be presented, and the questions, I mean, presented in the means that we will give you a present. I'm sorry for my English. And so for that, I am the woman of my word, so we will do that. So please, write us with feedback. My community manager, which I love the most, showing, pointing me with every sign language that we are asking for feedback, good or bad. It's very nice to hear what we can improve and make even more cozy for you guys. That's, we're all learning here of our biases and getting rid of our biases. And to someone who will enter the community, we'll just give there the results of the t-shirt sending for the questions, and we will ask our speakers to give their biased opinions on who was the best here. Please chill, please enjoy, please have the nice rest of the evening. Please applaud us for everything that we try to do today.